Welcome back to our second segment. We're still looking at the exploration of what exactly happens, to matter when there is a phase change that takes place. Now, we want to focus our attention on what exactly happens in terms of, the energy. We'll also try and incorporate some of the key terms that we discussed in the first segment. Now, without any waste of time, let's look at the detail behind, freezing is a phase change. Now, the key term that relates to that change of that state of matter is freezing point. Okay, what is freezing point? By definition, freezing point is the temperature. So it is actually the temperature. Okay, so freezing point is actually the temperature at which a liquid completely changes to a solid. So the change, the process involved is when a liquid changes to a solid. Okay, that's what this is, the process involved in terms of freezing. Okay, and then when a substance freezes, there is a change of phase. Okay, the change of phase is from liquid to solid, and now it's still the same substance. However, the state in which it exists is what has changed. So this is more of a physical change. Okay, so a physical change involves, a change of state of matter. However, the chemical properties of that material remains the same. The only thing that happens is that the substance changes from a liquid to a solid. Right, and then the freezing point of a substance will depend on how strong the forces, that exist between the particles of that substance. So as freezing occurs, it means that, remember, in terms of properties, the particles in a liquid, they're actually sliding past each other because the forces are comparatively weaker. So when freezing takes place, it means the packaging of particles also changes. Okay, it means the forces become stronger, which is why the substance becomes more compact, and then it assumes a certain shape for that matter. Okay, right. That's what it means in as far as freezing is concerned. Now let's focus our attention on melting point. Okay, so melting point is actually the temperature. I'll highlight the term temperature because it's actually more of what happens in as far as the energy is concerned. So the temperature at which a solid completely changes to a liquid is the melting point. So the phase change involved here is from solid to liquid. Okay, so it's from solid, changing to a liquid, which is actually the opposite of what happens when a substance melts. So this is also again a physical change. Why are we saying this is a physical change? Because the physical properties of the material will change, but it will still be the same material in terms of what makes up that material. Same particles, the only thing that's going to change here is the packaging. So when a substance actually melts, it means the forces become weaker, and the energy involved with that is that you have to, you heat a substance, and then once you heat, at a particular temperature, the solid will turn into a liquid. So that's the phase change that is involved in as far as melting. So at the melting point of a substance, the solid and the liquid phase are in equilibrium. Now, what this means is that we have a solid coexisting with a liquid. So this change actually is in the direction from solid to liquid. So when we talk about equilibrium, we talk about a state of balance. For now, let's think of it in terms of the state of balance between the two phases. Okay. Now, the melting point of a substance is also influenced by the strength of the forces that exist between particles. What does that mean? For us to say substance X has got a certain, melting point, what that simply means is that temperature is actually influenced by how strong the force is. So if a substance is got a higher melting point, what does it mean? It means we have to supply more energy. It means the change of the phase will happen at a comparatively higher temperature than for a substance that has got, a weaker forces between the particles, okay? So that's a very important thing to say, because when we will do a problem in the next segment, we'll talk about the relationship that exists between the strength of forces between the particles and the melting point, or the boiling point for that matter, which takes us to, the next slide, okay? So the temperature at which a substance, which a liquid substance in a liquid phase changes to a solid, that's the freezing point. We know that. Now, freezing is the reverse phase change of melting. So we've got solid, okay, to liquid, right? That's melting. So if we move in that direction, we heat. Then if we move from liquid to solid, we cool, okay? So cooling will, consequently result in a decrease in temperature. So if solid to liquid, that's the melting. So melting is actually the process. Now, at the melting point, this process or this change from solid to liquid would actually take place. And then from liquid to solid, that's the freezing. So freezing becomes the process involved when a liquid substance completely changes into a solid, okay? So this is the big idea in as far as the transition of state of matter between solid and liquid. We need to understand it in this context, okay? So freezing occurs when a substance is cooled. Now, this is the opposite of heating, okay? But melting will actually occur when a substance is heated. We don't talk of a, to say we increase the temperature. When you heat, the temperature will automatically increase. So the language, again, there is very, very important, okay? Now, let's talk about boiling point, okay? What is boiling point? Boiling point of a substance. So we want to qualify that. Is boiling point of a substance, because in the context, we must refer to a specific substance. So I've used substance X as an example, and it can be anything. So boiling point of a substance is actually the temperature, yet again, okay, at which vapor pressure of a substance is equal to the atmospheric pressure, okay? Now, boiling involves the transition or the change from liquid to gas, okay? Now, if we heat a liquid, what happens? It turns into a gas, or it vaporizes. Now, if it boils or evaporates, it simply means that now the forces between these particles of that substance, they become actually weaker. And then the opposite of that is actually condensation, which is one of the key terms that we spoke to. So if a gas or a substance condenses, it means we cool a gas, and then while we do that, the forces become weaker, the packaging or the physical properties of that material or that substance changes, and then that substance changes to a liquid from a gas. So the reverse process of boiling is actually condensation. So this is something that we maybe already know, but let's try and link the two in terms of how those two phases of matter relate to each other and the processes involved. Now we are able to distinguish between boiling point, okay, as in the temperature at which the vapor pressure equals that of the atmospheric pressure, as well as the process in itself which is involved, which is actually the boiling, right? Okay. Okay, now evaporation of a substance may occur at a temperature that is comparatively lower than its boiling point. Now, the key idea here is to say that the process of evaporation as well as the boiling point, this is a possibility. It does not follow that evaporation of a substance occurs at a boiling point. It can be lower. Why? Because this is entirely dependent, again, on the conditions under which it takes place. If you think of the boiling point of water, ordinarily would say it's 100 degrees Celsius, but it can actually be less than that, say 97. So it depends, again, in terms of the atmospheric pressure. So the process or the conditions under which the process takes place will influence the boiling point or the temperature at which that process actually occurs. Very, very important point, right? Okay. Now, the state in which a given substance exists depend on its melting point and boiling point, okay? Below is a list of substances and their respective boiling points and melting points. Now we want to determine the state. Remember, state, either solid, okay, liquid, or gas, right? So we are given 3 substances, okay, at room temperature, which is 23 degrees Celsius, okay? Now, we can think of this as our standard condition. We're saying that these substances, we are given these substances at a temperature of 23 degrees Celsius. Now, okay, now we have got iodine, bromine, and chlorine. The melting point of iodine is 113 degrees Celsius, okay, at an atmospheric pressure of 1 atmosphere. The very same substance boils at 184 degrees Celsius at 1 atmosphere, okay? So now we know the difference between melting and boiling point, okay? Now, having said that, we want to decide whether for each of these substances, at that temperature of 23 degrees Celsius, does it exist as a liquid, a solid, or a gas? Right. Now, at 23 degrees Celsius, okay, we have got iodine, which melts at 113, okay? So 23 degrees Celsius is actually lower than 113, okay? Now, it means then for iodine, at that temperature, it will still be in liquid form, okay? Right. But then, again, if you check, 184 degrees is actually the boiling point, okay? For iodine to turn into a gas, we must reach a temperature of 184, okay? Right. And then for it to melt, we need a temperature of 113. Now, let's look at bromine. Bromine melts at -8, all right? It melts at -8 and boils at 59. Now, we have to compare these 2 temperatures to the 23 degrees Celsius, okay? So if bromine melts at -8, okay, and 23 is greater than -8, then it means bromine will be a liquid, okay? While at 23 degrees Celsius, iodine will still be in solid form, okay? It's very important to note that. Then chlorine boils at -34 degrees and it melts at -102. So 23 degrees is actually greater than -102, okay? And also, it's also 23 greater than that. It means than -34. It means then chlorine will exist as a gas at 23 degrees Celsius, okay? Now, the long and short of this is that the state of matter is entirely dependent on the temperature at which that substance is given, and we also have to compare that to its melting and boiling point. So if a substance is, the temperature at which that substance is given is actually less than the melting point, then it will be a solid, okay? Now, if for example, the melting point and the boiling point of that substance is given, okay, and then the temperature which is given is actually, the melting point is less than the temperature that's given and less than the boiling point, that substance will actually be a liquid, okay? Now, we can use, this is 23 degrees Celsius, okay, is less than, if we can go back to the iodine, okay, is less than 113, okay? So if it's less than 113, it means this substance will be a solid, okay? 113 degrees Celsius. So it means this substance will be a solid. But then if you take 23 degrees Celsius, okay, which is the temperature at which, let's say for argument's sake, bromine is given. If you go back, you'll see that bromine melts at -8, okay? -8 is less than 23, but at the same time, 23 is less than 59. So if the temperature, that's given, which is 23 degrees, is between the melting point and the boiling point, that substance will be a liquid, right? The substance will be a liquid. And then if the temperature is given of that substance is actually greater than the boiling point, then that substance will be a gas. This is what actually happened with chlorine. in the previous example that we just spoke of, right? Okay. So these are some of the, the ideas to say, how do these, temperatures at which a phase change influence the state in which the substance actually exists. That's very, very important. So in the next segment, we'll try and look at exactly what happens in terms of, the energy, and we'll look at the heating curve of a substance, which is a very, very important part, which links with what we've just discussed in terms of how energy plays a role in as far as phase change of a substance is concerned. Let's take a short break for now.